side to another. If you have a glass of water in front of you or a cup of tea in front of you, if that is cylindrical in shape, obviously your glass is not full. The surface of the liquid in the glass, which will be circle, is the free surface, shape of the free surface for that particular glass or cup. If the shape of the cup is made square, then it will become square. So it is moment of inertia of which area? Free surface beta. Second is about which axis? About 4.5 axis. Why? Because it's again related to transverse stability. But 4.5 axis can be infinite. You can have so many 4.5 axis drawn on the ship. This is the 4.5 axis drawn through the GC of free surface. Now, some people tend to get confused between what we did yesterday and what we are doing today. So I don't want you to get confused. What we did yesterday was the water plane of the ship. That was the water plane of the whole ship, intact water plane. And the GC of that water plane is the center of flotation. What we are doing today, or what we are talking about today, is only the free surface in the concerned tank. Okay? And then we are talking about a 4.5 axis passing through that the geometric center of that free surface. In some cases, if the tank is on the center line, symmetrical on both sides, it may coincide with the ship center line, may. But if the tank is on the sides, then this axis is not going to coincide with the center line of the vessel. So please do not confuse this axis with the center line of the ship. Am I clear about it, beta?
Yes, sir.
Am I clear, beta? Which axis, which area? Is that clear?
Yes, sir.
Yes, sir.
So to solve these questions, what will be your requirement? First, identify the shape of the free surface. Second, identify its GC. Third, draw a 4.5 axis through the GC. And then, based your knowledge of moment of inertia, get I. Whether you get it directly through formula, or you get by curvilinear shape, or by theorem of parallel axis, that knowledge is what you have already acquired. That is the knowledge that will be subject to use. Any questions on what I have said, beta, on the screen, what is on display? What was being done yesterday? Yesterday, we are identifying the shape of the water plane. Then you were identifying the center of flotation of that, which was the GC of that water plane. Today, we are not talking of water plane. We are talking of free surface in a concerned tank. So is the difference with yesterday's working clear, beta? They should not be confused, right?
Yes, sir.
Yes.
Okay. Then, how do we get the GM of a vessel? Transverse, GMT. When I say GM, whether I say GMT or I say GM, they both mean the same. So when I refer to transverse GM, I may put the suffix T or I may not put it. Okay. But if I have to refer to GML, I must put suffix L. Okay. Secondly, if only GMT or GM is said, this will be GM fluid always. If you have to talk of GM solid, it has to be stated that you're talking about GM solid. Otherwise, by default, it will become GM fluid. And how do we calculate the km beta? Kg, sorry. We calculate from the km, we subtract the kg. This gives us gm solid. From here, we subtract the FSC, and this gives us the gm or gm fluid, whatever you want to say. I'm sure all this you're on top of. Any questions on whatever is explained on the slide, beta? Class, any questions on what I've said, beta?
No, sir.
Can
Yeah.
we continue then if no questions? Please
No, we can
remember
continue.
this. This will
Yes,
make
sir,
the
go ahead.
learning easier now. Today will be much faster, don't worry. Reason being, you have now practiced moment of inertia in 2 applications. Okay, then introduce FSM. I have already told you FSM is I into DI. Now let's look at this tank. The free surface of a 4-peak tank. Now what has he given me? He's given me directly the shape of the free surface. The shape of the free surface in a 4-peak tank is triangular with 12-meter width and 15-meter length. That means the free surface is like this, with 12-meter width and 15-meter length. You can correct me if you think I've missed out something. The 4-peak contains water of RD 1.005. We need to calculate the FSM. How do we think what we need to calculate? We see what is FSM equal to I into DI. DI is given in the question. So that means I need to calculate I. What is it that I have drawn? I have drawn the shape of the free surface. Do you agree with me, beta? Do you agree with me that I have drawn the shape of the free surface? Yes or no?
Yes.
Identify its geometric center. We did in the first class how to find the geometric center of a triangle. It will be intersection of the medians. G would be here. Yes or no, beta? Correct? Correct, guys?
Correct, sir.
Yes, sir.
Yes.
Now I draw a 4.5 axis through this G. Now in this case, it may be coinciding with the center line of the ship. I'm not interested in with the center line of the ship, whether it is coinciding with that or not coinciding. So in FSM questions, I would prefer to call it as either GG or XX rather than center line. Because then otherwise it can be confused with the center line of the vessel. For water plane area, that was for the full ship, and that line was actually the center line of the ship. Here, in this case, it may be center line of the ship because 4-peak is symmetrical about the center line, but for other questions, it may not be. So for such questions, my suggestion would be that you avoid using the word center line for such questions, so that you also know that you are not talking about what we did yesterday, BMT or BML. We are talking about the I or the free surface moment. Guys, so do you agree that based on our discussion that this I is nothing but I about GG of the free surface? Do you agree with me? Yes or no?
Yes, sir.
Correct, beta?
Yes, sir.
Yes or no? And into DI, if I make it, it will become FSM. How can I get the free I of this particular figure, beta, about GG? How can I get moment of inertia of this figure about GG? Tell me. We have already dealt with it.
1/3 of 15.
Huh?
सर दो ट्रायंगल ले लेंगे एक्सेस जो जीजी वाला है ना उस पे बीडी क्यूब बाय
I didn't ask. Beta, good. I didn't ask you what is the distance of G. You are saying 1/3 of 15. Here, you listen to the question at least. My question was, how do you calculate I of this figure about GG? That was the question. Okay. What he is saying is correct. We have dealt with it. Now, first I tell myself, is GG a standard axis for triangle? No. Answer is no. How can I then resolve my issue? I can resolve my issue by dividing this area into two triangles and which are exactly same, in which this will become 6, this will become 15. Now for this triangle 1 or half triangle, whatever you want to say, so it will be 2 into I of triangle 1, right, about GG multiplied by DI. I have just written this expression here. This is this part, is this one. Now, guys, I'm sure you can see through. What will be the I of triangle 1 about GG beta? Does it become a standard axis now? Yes or no? Does GG become a standard axis for triangle 1?
Yes, sir.
Yes.
Yes, sir.
So which formula do you use?
BD cube by
Which
12.
formula do you use?
BD cube by 12.
Cube by 12.
Okay, so what is B? Look at the diagram.
15.
6.
15 into 6 cube by 12.
Yes.
This is the I of the tank multiplied by 1.005 will give you the FSM. Units of FSM are ton meter, gentlemen. And the answer is 542.7 ton meter. Please calculate,
Yes, sir.
review. Let me know if there are any doubts.
सर ये BD क्यूब by 36 नहीं होगा क्या?
Which axis is BDQ by 36? Tell me. Can you identify yourself better?
Mudit sir.
So that means you have not been doing the questions that we have done over last 2 days, beta, is it?
Sir, sorry sir, yesterday I was absent sir.
So then you should have caught up by yourself, no, in consultation with your friends.
Yes sir.
Then you should have tried catching up, na beta. I cannot take you back to yesterday's class today. And this has nothing to do with the yesterday's class either. It has got to do with the day before yesterday's class.
I'll check sir, I'll check.
So is that clear, guys? 542.7 ton meter.
Yeah, clear, sir.
This is
Yes, sir.
irresponsible behavior anyway.
Yes,
That's
sir.
your loss. Okay. We go to the next one. A ballast tank is bound by ship side on the outboard side and a longitudinal bulkhead on the inboard side. The breadths of the free surface of the tank are measured at equispaced interval of 4 meters from forward are 3, 5, 8, and 13. Find the FSM of the tank when it is partly filled with seawater of RD 1.010. Guys, can you read this question and try to visualize the shape of the free surface? What will be the shape of the free surface? And these are the breadths of the free surface. Mind you, the question says these are the breadths of the free surface. It's bound by the ship's hull on the outboard side, a fore and aft bulkhead on the inboard side, the tank, we are talking of the tank. And then how will the free surface look like? Do you think this is how the free surface will look like, Vita? This is the inboard side. This is the outboard side. This is the forward end of the tank. This is the aft end of the tank. Yes or no, beta? Would the tank free surface look like this? Yes or no? Please read the question and try to visualize. If you're not able to visualize, let me know. Yes or no, beta?
No, sir.
No, okay. Which type of ship have you sailed upon, beta?
The container.
Container, okay. Have you been in the ballast tank?
Yes, sir.
Okay. You had the side tanks, is it? It was a double hull container, right?
Yes, sir.
If you have ever, if the ballast, having ballast in the side tank of the ship in the forward end, okay, forget about it. Have you been ever in the forepeak tank?
Yes, sir.
Suppose the center line bulkhead is fully intact. Suppose, though in the forepeak, the center line bulkhead, you have the manholes for passing from one side to another. Suppose the
Yeah.
center line bulkhead is fully there, and let us say I divide the forepeak into port and starboard two sides. Okay, beta? Okay.
Yeah.
Now let us say the starboard side is partly filled up. Okay. What
Okay.
will be the shape of that free surface in the forepeak then?
Yeah,
The
then
breadth
it
at the
will
forward
like,
end will be negligible, correct?
yeah. Yes, sir.
And if you're seeing from top, the center line
Yes.
bulkhead, here the free surface will look like this, correct?
Yeah.
Then you will have somewhere maybe the chain locker here, free surface will look like this, correct?
Yes, sir.
And then you will have the outboard side, the free surface of the forepeak will look like this, correct? If I take the half, and of course it's
Yes,
the
sir.
same on the other side. Do you agree?
Yes. Yes, sir. Yes. Yes.
Now, with respect to this question, do you now agree with the diagram? Tell me now.
Yes, sir.
Anybody else who has problem in comprehending the diagram better? Everybody else is aligned with the diagram, right?
Yes, sir.
Okay.
Yes.
Okay. So here is
Yes.
what have I drawn is the free surface. The breadths of the free surface will be running from center line outwards, obviously from the inboard side to outboard side. Those will be the breadths. Obviously, these are going to be the breadths of this free surface. They are 3 meters, 5 meters, 8 meters, and 13 meters. Does everybody know? Agree with me? Yes or no?
Yes, sir.
Now, what I'm doing is only for explanation. Suppose the geometric center of this free surface is here. For I, what do I have to do? I have to draw a fore and aft axis through G. Yes or no, beta? Am I correct?
Yes. Yes, sir.
I can call it XX, GG, whatever I want to call it, no problem. So what will I need basically? I will need I of this free surface. What area? This area. I will need I of this area about GG. And then if I multiply with 1.010, this will become the answer to the question. First, agree with the concept.
Yeah, this is the okay, sir. But so for finding G, we will find
Arey
out
yaar,
by
ruk
the
jana. What did I say? First, agree with the concept. Did I say that let's talk about the procedure?
no,
तुम
sir.
सुनते नहीं हो ना,
Okay.
तो you guys don't listen to what I'm saying.
Okay, sir.
You are on your
Understood.
own trip all the time. Guys, do you agree with the concept that if I can
Yes,
find
sir.
IGG, my problem will be solved?
Yes, sir.
Okay. With respect to IGG, then is it a case of horizontal ordinates or vertical ordinates?
Horizontal ordinate.
It's a case of horizontal ordinates.
Vertical.
Vertical ordinate. Yes, sir. Vertical ordinate. Sorry.
It's a case of vertical ordinate. So can I take GG as the axis for vertical ordinates? Were our formulae derived like this? Can I use GG for the formulae?
No, sir.
What do I have to use then? Look at the diagram and tell me, what do I have to use?
Reference axis.
Which axis?
Half per
Longitudinal bulkhead. Center line.
Not center line, this axis.
Inward.
Who said this is the center line?
Center line.
Inboard side. Inboard side. Bete. Correct answer is the inboard side. Yes or no? Correct, bete?
Yes. Yes.
Okay, now I'll delete it and now take you through. So here are the ordinates. Now I cannot work about GG, nor do I know the location of GG. Nor do I know the location of G actually, which somebody was saying a while back. So I'll have to take this axis. Am I right, beta?
Yes, sir.
Yes, sir.
Correct. So now can you make the table for vertical ordinates about XX, beta? I
Yes,
have it
sir.
solved completely. I solved it, in fact, before the class.
Yes.
Will the table structure be like this? Ordinate, Simpson's multiplier, product of area, repeat the ordinate, product of moment about XX, then ordinate, product of inertia about XX. Do you agree with the structure of the table, guys?
Yes, sir.
Yes.
Okay.
Excuse me, sir, can you please repeat, sir, why did we take this XX? My connection was lost in between, sir.
You tell me, how do we solve for vertical ordinates, beta? Based on yesterday, we had quite a few questions done, na bete? So you tell me which axis should I be taking otherwise? What is your take? How do I solve it? Speak up, yeah. Don't go underground.
Axis basically should culminate, means where the
Correct.
should culminate
I
at.
just explained a while back that if firstly for I, we need moment of inertia of this area about a 4.5 axis through G. Okay, I don't know G, but let me just hypothetically tell you G is here. Then what will you have to do? You'll have to draw 4.5 axis through it. Yes or no?
Yes, sir, correct, sir.
So is it a case of now vertical ordinates or horizontal ordinates?
Vertical ordinates.
About G and the ordinates, it's a case of vertical ordinates. But then vertical ordinates, can I make the table about GG? Are all the ordinates terminating at GG?
Not in, yes, okay, got it, sir, okay. And
Okay, guys. So we take XX, and does everybody now agree with the structure of the table, guys?
Yes, sir.
This is what we have used yesterday also, day before yesterday also. Only thing is area has changed. Axis has changed. We did it in COP. We did it in BML, BMT. Ordinate, Simpson's multiplier 1331. And now we complete the table. Can you get me the summation? I have already done it. You can check it. And then you'll get the SOPs for area, moment, and inertia by making for moment half and for inertia 1/3. And these are the SOPs. Can you please complete the table? Don't just say yes, otherwise you'll miss out on the things. Let me know if you still have any doubt. I digitized this question just before the class actually.
Yes, sir, correct, sir.
Okay. Anybody wants me to wait? If you're solving, let me know.
No, sir, already.
Oh, yes,
Done,
just,
okay.
just 1 minute, sir. 1 minute. Sir.
Okay, let me know once you're done. No issues. Take 2 minutes here. No hurry, beta. As long as you're using the time, it's fine. Those who have made the table can calculate area in D. Distance of GC from XX. Please calculate that.
Yes, sir.
Okay, all of you to calculate the area of the free surface, calculate the area, and calculate the distance of the geometric center of this free surface from XX.
Area is 82.5
Okay, and DXX.
and D 4.045.
Okay, Very good. Anybody who's having problems in calculating area and dxx, please let me know. If you are having a problem, please share. You may just get a little, I may express my displeasure, but please keep asking your questions. Okay, area is 82.5 square meters, guys. Anybody has any doubt?
No, sir.
Okay, yeah, tell me. Beta, you had a doubt or something, or you're just confirming the area? Okay, what is the dxx you are getting, guys?
Decimal
4.045.
Yeah, very good. 4.045, correct? Yes or no?
Correct, sir. Correct.
Okay. Now, I don't know the exact location of G, but I'm just marking for the purpose of explaining you. Let us say the G is here. It can be vertical, it can be in 4.5 direction, it can be little up or down. That is not what we have calculated. I have marked it here just for the purpose of explaining to you. That means this is the distance 4.045 meters. Am I right, guys? Yes or no?
Right. Right, sir.
Yes, sir.
Now what do? Now I draw a 4.5 axis through G, because now I know where in the athwartship direction is G located. Whether it is forward or aft does not make a difference. The 4.5 axis will still remain the same, guys. So I draw a 4.5 axis through G and I call it GG. Understood?
Yes.
All in line with what we have just discussed. Yes or no?
Yes.
Now, how do I get FSM? Who's going to answer? Not the FSM value. What do I need to calculate to get the FSM now? IXX or IGG?
IGG.
The table is going to give me what? IGG or IXX?
IXX.
IXS.
So now think. Again, think. How do I get IGG from IXX?
Minus AD.
Here.
Minus, sir.
Very
Minus,
good.
sir.
Very
Minus
good.
AD square.
Very good. You see,
Minus.
on the day one, bulk of you had problem. Yesterday, some of you had the problem. Now, most of you do not have the problem. Some of you may still have. Please remember, you are coming from XX to a axis through the geometric center. So it will be minus AD square. IGG will be equal to IXX minus area into DXX square. Yes or no? Look at the expression coming on which has come on the screen.
Yes, sir.
Please calculate IGG then. Put the values, calculate IGG. I'll show you the answer then.
717.361.
Okay, very good. Multiply by 1.010 and see if the answer is matching. That is the test of correctness.
724.534.
It's there on top answer, yeah. Please let me know if somebody is not able to get the answer, then I'll show it to you. Otherwise, we'll just keep. Sorry, beta.
Correct, sir. 724.
Oh, very good. Anybody who's not getting the answer, please do not hesitate. Do not hesitate if you're not getting the answers. Please speak up. I can explain to you. So here is, this is IXX. This is IXX, guys. And this is AD square. And then the FSM is equal to 724.809. That completes the question. Hey guys, you tell me one thing for future batches. If I digitize, is it better to understand, or if I'm doing by pen, is it better? Because then I can accordingly take a call here.
So by pen, sir.
Pen is better.
Pen is better, no? Okay, fine. Then part I'll do the hybrid then. Some things I'll have on the screen and the final steps I'll do by pen in pen then. No issues. But this is understood, right?
Yes, sir.
Yes, sir. Digitize से sir time बच जा रहा है तो it is better.
बट बेटा टाइम बचा के तो स्पीड तो ले लेंगे बट फिर कुछ बंदे पीछे रह जाएंगे they'll not be able to understand. For me it will be good. I'll be able to complete the thing in 12 days instead of 15, right?
Correct, sir. 15 दिन में हमको पूरा step खत्म करना है.
But problem will be with some of the people will lag behind them badly and then they'll keep asking for PDF and then it is like a book from where you'll see what happens is in this digitized one that initially only XXX came, then GG came. So you know how to proceed actually. It should not be the full diagram coming in front of you with GG, XX, everything drawn. Then there is a confusion. Anyway, let's continue. So now the concept is today, you see your comfort level will automatically increase with moment of inertia. And if you're comfortable, then you don't have to break your head with too many books now. Let's do this question. Is it an MMD question? No, it's not an MMD question, but कोई बात नहीं. A box-shaped vessel, 40. Now this I'll have to do in pen. I have not done anything on this. A box-shaped vessel, 40 meter long, 10 meter wide, is floating at a draft of 3 meters in sea water. So here is the vessel. This is the water line where she is floating at a draft of 3 meters in sea water. Okay. The kg of this vessel in the initial condition, that means kg in the initial condition is 3.5 meters. And FSC is in the initial condition 0.080 meters. This will take you through the concept of free surface correction completely now. It has an empty cuboidal DB tank. It may be anywhere along the length. Yesterday, somebody asked me, I said we work for even keel upright conditions. Okay. So just to keep it simple, I am keeping it here. Let's say there is a DB tank here, which is 10 meter long and 5 meter wide and 2 meters in height. You don't have to make this DB like this. This 3D I'm trying to create only for you. Okay. You can just keep it straight. Find the GM of the vessel. Now, initially, when kg was so much and draft was 3 meters, the DB is set to be empty. Please read the question carefully. It has an empty cuboidal DB tank. Now, you have to find the GM of the vessel. When GM is given, by default, it becomes GMT, not GML. Of the vessel after the DB is ballasted to a sounding of 1 meter. You basically ballast the DB to sounding of 1 meter. Have you understood the question in context of the diagram, beta?
Yes, sir.
Okay, guys. Now you see, how do we start? We start working backwards. How do I figure out what I have to do? I start working backwards. What does the question say? Question says I have to get the GM in the final condition. And I know what is GM equal to. GM is equal to KM minus KG minus FSC. If I get the KM in the final condition, if I get the KG in the final condition, if I get the FSC in the final condition, my job will be done. Okay. And what is KM? Yesterday we learned. So this is applying what we did yesterday and what we are doing today. KM is equal to KB in the final condition plus the BM in the final condition. This is KM minus KG in the final condition minus FSC in the final condition will give me the GM in the final condition. Yes or no, beta, do you agree that this is my final solution? Guys, do you agree this is the final solution?
Yes.
So basically, now we will calculate all these things, 4 things one by one. And once I have all the four things, I'll just put them in this formula and I'll get my answer. Understood, beta? Is the concept clear?
Yes, sir.
Okay. Also, so firstly, what is the initial displacement? Initial displacement is we can find by law of flotation, length 40 meters, breadth 10 meters, draft 3 meters, floating in sea water. Can you please pick up the calculator and give me the initial displacement, beta?
1230, sir.
1230 tons. This is law of flotation. So basics will be put to use. Okay. What is kg initial? It's given in the question 3.5 meters. Guys, I'll ask you a question and I'll correct if you're wrong. If I am given the initial FSC and there is another surface, free surface is created, how can I get the final FSC? Would somebody like to revise quickly?
So we can find the
We-
FS.
Very good.
Find
Very,
the
very, very
find the
good.
FS.
You have to
Find the
find the
FSM.
final FSM, which will be initial
Yes, sir.
FSM plus minus the change. Yes or no?
Yes, sir. Yes, sir. Or either displacement.
Very good. Very good. Very good. Very good.
Yes.
So, what guys? I'm just writing for explaining. FSC is equal to FSM upon W,
W, yes, sir.
and you can get FSM is equal to FSC into W. Okay. So now I'm writing
Yes,
FSM initial will be equal to initial FSC is 0.080. Displacement is 1230. How many ton meter is the initial FSM, beta? How much is the initial FSM?
98.4.
98.4 ton meter. Okay, fantastic. Now we come to what change has been made to the vessel. How much ballast has been added? The tank is cuboidal, rectangular. So W, small w, that is the ballast weight, will be equal to the volume of the water. The tank dimensions are 10 meter long, 5 meter wide, 1 meter sounding, and seawater, or if density is not given, 1.025. How much is the water ballast taken, guys?
51.25.
51 point.
51.25.
Okay. If 51.25 tons is the water ballast taken, that gives us the displacement in the final condition will be 1230, the initial displacement, plus 51.25, that is 1281.25 tons. Am I right, guys?
Yes, sir.
I'll write the final values here. Displacement final is 1281.25 tons. Okay. Guys, where will be the kg of the water ballast? How much will be the kg of the ballast?
0.5.
Read the question.
Yes, sir.
0.5.
0.5.
0.5 meters. It will be half the sounding because it's a cuboidal tank. It's a rectangular tank. Correct, Vacho?
Yes, sir.
Okay. Now, this will give me, okay. Okay, let's start calculating one by one. Let's start with KB. To get KB, what should I be calculating, beta, in the final condition? To get KB, what should I calculate?
Final draft. Final draft, sir.
Final draft.
Final
Very good.
draft.
And we don't have to write too many statements. Draft final will be equal to the final displacement, which is 1281.25. If I divide it with the density of the sea water, it becomes the underwater volume or volume of displacement. And it's a box shaped vessel. So if I divide with the length and the breadth of the vessel, will I get the draft final? Yes or no, beta?
Yes, sir.
You talk to yourself like this and just finish off in one line. You don't have to give lengthy explanation. You are writing phase 2 exam, not a pre-C exam, okay? So draft final will be, I'm talking to myself, final displacement divided by 1.025 divided by the length of the vessel and the breadth of the vessel gives me the final draft. How much does it come to?
3.125.
3.125. Guys, in a box shaped vessel, what will be KB final then?
Half of draft.
Draft
Half of
final by 2. It will be 1.563 meters if you round off. So KB final is equal to 1.563 meters. Is the KB calculation clear to everybody?
Yes, sir.
Understood, beta?
Hmm.
Anybody has any questions up to KB? Then I go to the next thing. Whatever is in my formula, I'll calculate them one by one. Next, we'll take BM, then we'll take KG, then we'll take FSC.
Yeah, KB is final.
KB is fine, okay. Now, next is BMT. It is BMT, which is final that you want.
Yes.
For now, my question to you is based on yesterday's discussion. For BM, what do I need to visualize? What do I need? Name the thing that I
Water
need to
plane area.
visualize.
Water plane area.
Shape of
Rectangle.
Water plane. Very
Plane.
good. What will be the shape
Yes,
of the
sir.
water plane in this case?
Rectangular.
Rectangle.
Rectangular. Okay, very good. Is it an intact vessel? Okay. Okay, chalo, theek hai, I'll do the by first principle, no problem. So for now, what I'm drawing here is the shape of the water plane. Okay, guys, this is the water plane. Length of the water plane is 40 meters. Breadth of the water plane is 10 meters. Where is the geometric center? Here. This is the center line of the vessel. Yes. So what is BMT equal to? BM will be equal to I about the center line. It will be L P cube by 12 divided by volume of displacement in the final condition. In the final condition, the volume of displacement is either you can use the displacement or you can use length into breadth into final draft. So length is 40, breadth is 10, final draft is calculated to be 3.125. So it is basically B square by 12D. And how much is the BM we are getting, beta? How many meters? BMT final
2.667.
0.666. So it will become 0.667. Am I right?
2.667.
2.66. Okay, okay, beta. 2.667. Okay, sorry. Guys, please review the BM calculation and tell me if there is any question to be asked. If there is any question about the BM which needs to be clarified, please feel free to ask. It's revising practically yesterday's working, today's working, FSC, KG, all the concepts will be revisited through this law of flotation. Everybody good with BM? KB, you are good. BM, you are good. Am I right, guys? Two parameters you are done with.
Yes, sir.
Okay. Now the next is KG. KG is relatively simple. I can change to red marker or green marker so that I can use this little space on the side. Okay. Guys, KG, talk to yourself like this. KG final will be equal to initial vertical moment. That means initial displacement into initial KG. Initial displacement is 1230. 1230. Initial kg is 3.5 given in the question. That is the initial vertical movement. Plus the vertical moments of all the weights loaded minus the vertical moment of all the weights discharged plus minus the change in vertical moment for shifting. In our question, it's only loading, add of weight.
Yes.
What happened? Okay. Am I back? Can you hear me? I think there was a momentary disruption. Am I there, beta?
Yes, sir.
Yes, sir.
Okay. Okay, there was a momentary flicker. Okay, fine. Okay. Weight of the water ballast is 51.25. kg of the water
Into
ballast is 0.5. Final
0.5.
displacement is 1281.25. How much is the kg we are getting, guys?
$3.38.
Sorry,
Sir, 3.38.
380, is it?
3.38, sir. 3.38.
380, correct? The third decimal place is 0. That's what you're saying, right?
Yeah. 3.380, sir.
Correct.
Okay,
Yes.
3.380. Thanks.
Yes.
So we have got kb, we have got bm, we have got kg, and kg you will calculate like this only in one line, beta. Keep talking, keep doing. Now we come to FSC. For FSC, I asked myself a question. Is there any tank that has become slack or any tank which was earlier? Is any free surface created or is any free surface removed? Is there a change in free surface?
Yes, sir. In that ballast tank creation.
Yeah, so there is a creation of free surface. Yes or no? In some
Yes,
cases,
sir. Yes.
Yes, sir.
earlier slack tank, if I say a half full tank I deballast, that will be removal of the free surface. Yes or no, beta? But
Yes,
in this
sir.
case, the free surface is created. Okay.
Yes, sir.
How do I get the FSM created, guys? Tell me what. Look at the question. Look at the drawing. What will be the shape of the free surface? Now I'm not asking you water plane. I'm drawing free surface here now.
Rectangle.
Rectangular.
What will be the dimensions of the free surface?
Yes, sir. Into 10
LB cube
into,
upon 12.
अरे dimensions
10 into 10.
क्वेश्चन तो
into
सुनना ही
1.
नहीं मैंने
10
जो
into
बोलना है
1
वही
into
बोलूंगा है ना रेक्टेंगल के डायमेंशंस
10
10
into
into
10.
1.
10 अजय
10 into 1.
5. 10 into
10
5.
into
10 into 5 into 1.
area
10
has
into
3 dimensions
5 cube. Sir, 10 into
Into
तुम
5.
मुझसे
10.
पिटोगे अगर if you're in a physical class ना
10 into 5.
you thank your stars
Sir,
you're not in a physical class area for an area somebody is telling you
10
10
into
into 5 into 2
10 into 5, sir. 10 into 5.
10 into 5 everybody agrees now 10 into 5 is the area of the free surface. Does everybody agree?
Yes, sir. Yes, sir. Yes, sir. 10 into 5. Yes.
It's a rectangle measuring 10 by 5. Where will be the geometric? Next is after having identified the free surface. Next, I identify its geometric center. I don't call it as F. It is the geometric center of the free surface. I call it G. Then I draw 4.5 axis through it. 10 meters is the length of the tank. So this becomes GG. Yes or no, beta? Yes or no?
Yes, sir.
So FSM caused FSMC will be equal to I of the free surface, IgG, into density of the tank content. IgG will be equal to 10 into 5 cube upon 12. Density is 1.025. So how many ton meter is the FSM caused, guys? How many tons is the FSM caused?
106.78.
780.
Sorry.
Does everybody agree with him?
No, sorry, 77, sir. You can take 106.77.
7.
Yes.
700 or 770?
770.
Okay. Guys, has everybody understood how the FSM cost has been found? Or any doubts? So here, this was water plane that I drew. Here, this is the free surface that I'm drawing. Please be careful. And you can draw them in your notebook while you're doing a small diagram and solve it. It will help you in solution. Was there in any initial FSM? Yes. How much was it? 98.4. We have calculated it here. So what will be the final FSM, guys? Sum of these two, 7, 0, 11, 1, 14, 1, 15, 205.170 ton meter. Yes or no? Correct, beta?
Yes,
Sir.
yes, sir.
Yes, sir.
Then what will be the final FSC? Final FSC will be equal to final FSM will be equal to final FSM, that is 205.17 divided by final displacement of 1281.25. How much is the final FSC, guys?
0.160.
0.160, is it?
Yes, sir.
Okay. Now we have all the four things that are required to get the GM. We can get the answer by adding, subtracting them.
Excuse me, sir.
Tell me.
सर एक बार सर FSM चेक कर सकते हैं सर, मेरा आंसर कुछ और आ रहा है
बताओ भाई, what is FSM correct बेटा?
सर FSM मेरा 106.77 आ रहा है, मोमेंट ऑफ इनर्शिया 104.
उतना ही तो है, that उतना ही आ रहा है बेटा. FSM is 106.77, that's correct. So you'll add the initial FSM to it. No, that is the FSM cost beta. That is what is created by the in the ballast tank, right?
Yes sir, yes sir. Sorry.
So cost is 106.77. That's fine. What we have done to that is we have added the FSM initial 98.4. ये यहाँ पर calculate जो किया था 0.080 into 1230.
Yes.
Correct, sir.
Here. This box where I'm making, this is the initial FSM. Can you see the green box?
Yes. Yes sir, yes sir. Yes.
ज़्यादा ऊंचा है क्या?
Okay, now we close out the question. So GM final will be KB is how much? It's written here 1.563. What is BM final? BM final is 2.667. What is KG final? It is 3.380. What is FSC? It is 0.160. And we get this answer of 0.690. If we are not getting, then we have missed out something somewhere. The answer is 0.690 meters.
सर क्वेश्चन
Yeah, tell me बेटा.
सर जो सर BMT अपन निकाला था ना I/V करके, उसमें अपन ने ये जो अपना टैंक था उसको कंसिडर नहीं किया था, छोटे वाले टैंक को.
BMT में टैंक कहाँ से? BMT तो शिप का कैलकुलेट होता है ना. BMT में टैंक का BMT कब निकालने लगे तुम भाई?
नहीं सर, सुनिए ना सर.
BMT is for the ship or for the tank?
फॉर शिप ओनली, बट जब हमने I/V निकाला था ना, I/V जब किया था,
हाँ,
तो
क्या ड्राफ्ट लिया? कौन सा ड्राफ्ट लिया हमने? देखो,
ठीक है
what
सर.
draft have you taken?
शिप का
No, शिप का तो ठीक है, but which draft? Final draft, no?
3.125. ठीक है सर.
So this will give you final BM, no? If you have taken final draft, had you taken it 3, it will give you BM initial, right?
समझ गया सर, हो गया.
Okay. Somebody else was also having a question. Please go ahead.
नहीं सर, आ गया
सर एक्चुअली मेरे को ये डाउट हो गया था सर, जो हमने ये निकाला है, मोमेंट ऑफ इनर्शिया निकाला है विद रिस्पेक्ट टू द टैंक.
नहीं, are you talking of BM or you're talking of FSC? First tell me that.
I'm talking about sir FSC.
Yeah, okay.
FSC तो सर समझ आ गया, जो सर हम लोग
नहीं, एक मिनट. Your doubt, हमने दो जगह moment of inertia use किया. We've used moment of inertia at 2 places. One is in BM, other is in FSC. Your doubt is in which part of it?
Sir, in the first part.
अरे नाम ले लेना, FSC और BM यार. FSM और BM. Okay, what is the doubt? Tell me now.
सर जो हमने initial BMT निकाला,
Initial BMT कब निकाला? We didn't calculate any initial BMT. When did we calculate the initial BMT? Why do I need the initial BMT, बेटा?
ताकि हम लोग एक सर मतलब मैंने उसका KM निकालने के लिए BMT कर लिया था, मैंने उधर ही KM निकाल दिया.
But वो तो initial KM आएगा ना, उसका क्या करोगे तुम?
करेक्ट. हाँ, वो मैंने सर उस समय मैं
You have to use the final KM, no? No.
Correct.
Listen to me. You have to use the final KM, correct? You're talking of final GM, na bete?
Yes, sir. Yes.
The
sir.
question wants GM in the final condition after the ballast is taken. Yes or no?
Yes, sir.
So be it KB, be it BM, be it kg or FSC, be it any of these four things, they will all be for the final condition. Then only you'll get the final GM, no?
Yes. Understood, sir. Understood.
Okay. Okay. So,
So I wanted to ask something.
yeah, tell me.
So in the start, when we were starting free surface effect, you said that not to confuse it with the water plane area, but actually in this case, this is the free surface. It is the water plane of the water inside the tank, right?
Yeah, yeah.
Okay.
How can it be the water plane of the water surface? Water plane is a term associated with the ship, the area occupied by the ship at the water line.
Yes, sir, that is correct. But
So how can you misuse a term? Is it the area of the ship at the water line?
no, it's not the area of the ship.
So how can it be called water plane, beta? That is the mistake you're making, no?
अच्छा ठीक है, okay, all right.
It can't be called water plane, no? Then.
ठीक है sir, ठीक है, okay, got it.
No, still you can keep telling me, but what I'm trying to say is water plane is a technical term. It's not a literary term ki wherever there is a plane of the water, we call it water plane.
Okay, sir, understood. So we'll call it.
It's a technical term and will be used only the way it is defined as far as ship stability is concerned. Correct, beta?
Yes, sir, correct.
Okay, so.
ठीक है, तो समझ गया.
It does not mean plane of any water. In our context, okay?
Sir.
In our context, it does not mean plane of any water, right?
Okay, I got it, sir.
Okay, fine. No, it's okay. Guys, any more questions? A good question. Just see how many things it has forced you to revise. It started with law of flotation to get initial displacement, then again law of flotation to get the final displacement, your density volume concept, then your kg concept, then your FSC concept, then your BM concept. It has put you through and through everything. So, all satisfied about this one, guys? Good. Chalo. Can I go to the next one if it's okay?
Yes.
Okay. I don't remember which year it was, but I'm sure some of you would have seen this question in the past papers, right? So it's definitely from MMD exams. I think a while back. It's not one of the very recent ones, but yes, it's a MMD question paper. Two pontoons consist of two cylinders floating in water of RD 1.025 with their axis perpendicular to the water line. And they are joined on top by a wooden deck. It is like on the ships we used to make raft in our days as cadets. But of course, we did not use the drum with vertical axis. We used to have the drums lying horizontal. And we used to connect a few drums in a frame of wood and put a wooden deck. And that we used to use for painting draft marks, etc. So it is something like this. Only thing is here is saying the cylinders are with axis perpendicular to the water line. Diameter of each cylinder is 4 meters and the distance between the cylinders center to center is 5 meters. Pontoon is floating at an even keel draft of 4 meters in its light condition. Why it's light condition? Because he goes on to say, and has a light kg of 3.6 meters. So obviously the draft is also the light draft. Seawater is taken then into each of the cylinders to a height of 2 meters and a load of 2 tons, kg 15 meters is placed on deck. 2 meters from the center line. Calculate the list produced. Is the question. Any clarifications required in the language of the question? Please let me sort out that first. The language of the question is clear, guys? Bachcho, clear? Okay. Now, how do we start? Now you'll say, sir, you are telling us because you have done these questions. No, I'm not telling you because I've done these questions. I'm telling you, how will you think your way out of these questions? Okay. What does he want me to calculate? He wants me to calculate the list. So that means I'll have to recall the formula of list and see from that formula what all I need to calculate in the final condition after the cylinders have been ballasted. Am I right, guys? Yes or no? Is this the way you'll approach the question? You'll recall the list formula and then you'll be driven to find out what you need to calculate. Am I right? Yes or no? Okay. So let's start with this. What is the list formula, guys? Anybody wants to revise? Tan theta formula.
Tan theta is
GG1 upon GG.
Tan theta is equal to GG1 transverse upon GM. GM is GM fluid, of course. And how do we get GG1 transverse? Listing moment
into
upon the
distance.
displacement multiplied by GM. Yes or no, divided by GM. Yes or no, beta? Do you all agree with this list formula that I have written here?
Yes, sir.
Yes, sir.
Okay, so that means now you need to get these. Read the question. Do you know what is small w in the question? Yes or no? Do you know the small w? Read the question and see if you know the small w.
2 ton is small. 2 ton.
Is how much?
2 ton. 2 ton.
2 tons. Weight. Very good. 2 tons. Very good. Do you know the d in this formula, in this question? What is the value of d? Read the question and tell me.
Yes, sir.
2 meters.
2 meters. 2 meters. Does everybody agree? Okay. So numerator is clear. No problem. What I need displacement final and I need GM final. Do you agree with this problem that is left now pending? Yes or no? Correct, beta?
Yes, sir. Yes, sir. Correct, sir.
And we just did, how do I get the GM? GM will be equal to KB plus KM to get me the, KB plus BM to give me the KM minus KG minus FSC. Do you agree? Now this is my problem statement. What do I need to get? I need to get final displacement. I need to get final KB. I need to get final BM. I need to get final KG. And I need to get final FSC. If I can get all these, can I get the list? Yes or no?
Yes, sir.
This is how you think through the question, beta. If I just start showing you the solution, then you'll again get stuck in some other question. It is always a reverse process. It's a reverse process to understand what is required. And it takes only 15 seconds. And now I'll take you through and I will focus on what is to be calculated. That is already written here on the right side bottom of it. That is the first thing I wanted to do with you. Now here is one cylinder. Here is the other cylinder. They are connected on top by deck. Have you understood what the question is meaning? Yes or no? The diameter of each one of them is 4 meters. And from center to center, it is 5 meters. As per the question. So that means there is a 1 meter gap between the cylinders. Do you agree with the diagram? Read the question. Do you agree with it? Yes or no?
Yes, sir.
This is the pontoon in its light condition. That means there are no weights on it. In this condition, it is floating at a draft of 4 meters even keel in sea water. Okay, that is the center line of the pontoon, and it is floating at this draft of 4 meters. Do you agree with me? This is the light pontoon draft. Yes or no, beta? Guys, do you agree?
Yes, sir.
Yes, sir.
How can I get the initial displacement in this? Underwater volume into density. How do I get the underwater volume, guys?
Pi r square h into 4.
Okay. Pi r square h into 4.
Yes. Volume of cylinder into
Sir,
1.0.
area into draft into
Acha,
density.
1.02. Hai na? So volume of the cylinder, volume of the full cylinder.
No,
Pi
sir,
r
only
square b into 2.
If you tell yourself like this, underwater volume of the both the cylinders, yes or no, beta, into the density, correct? Correct,
Yeah.
guys? Am I right? We are talking of
yes, sir.
this volume plus this volume multiplied by 1.025. Am I right?
Yes, sir.
So that means volume of one cylinder under the water below the water line multiplied by 2. One cylinder will be pi. Area of the base is pi. R square, R is 2. Because diameter is 4, so R will be 2. Pi R square into the draft of 4. Does this become the volume of one cylinder? Yes or no, guys? What I have written. Underwater volume of one cylinder. Do you agree? I'm only writing for understanding purposes.
Yes, sir.
Underwater volume of one drum, one cylinder, right, beta? Correct? Multiply by 2, it becomes the total underwater volume. Multiply by the density of the seawater. Does it become the displacement of the pontoon? Yes or no? Light displacement of the pontoon.
Yes, sir.
Guys, let me
Yes,
know
sir.
if
Yes, sir.
anybody
Correct,
has
sir.
any question. Calculate and give me the answer. Plus, if you have any doubts, let me know.
103.085.
103.086.
6.
So let me just take it 103.1 tons. Okay.
Okay, sir.
Okay. Guys, everybody happy with the initial light displacement of the pontoon or the initial displacement of the pontoon? If you have any doubts, please clarify. It should not happen that we go towards the end and you are still struggling with the first step. Now what happens? You take ballast into these cylinders up to a sounding of, if I'm not mistaken, 2 meters. Yes or no? Correct, beta?
Yes, sir. सर एक डाउट है सर.
Yeah, tell me.
सर ये अंडर वाटर वॉल्यूम तो दोनों सिलेंडर का निकाल लिया, बट जो बीच में 1 मीटर डिस्टेंस बचा है सर, उसको हम
तो वहां पे क्या, is that water displaced or that is sea water? How much is the water displaced by the pontoon? Beta,
जी सर.
how much water is displaced by the pontoon?
ये अंडर वाटर वॉल्यूम जो
Acha, why are you worried about this water? Why not about the water here? What about this water then? If this water is bothering you, then why not the water on the other side of the cylinder? Why only the water in between the two cylinders is bothering you? Tell me, what is the difference between the two?
नहीं एक्चुअली सर क्वेश्चन में वो डिस्टेंस बिटवीन दे रखा है ना सर 5
तो
मीटर.
डिस्टेंस तो दिया है, बट उससे क्या डिस्टेंस तो अगर वो दे रखा है तो हाउ डज द डिस्टेंस, सपोज द डिस्टेंस वाज मेड 2 meters, देन व्हाट हैपेंस?
तो सर बीच में गैप नहीं रहता ना, तो मे भी शायद
नहीं,
थोड़ा
मैं तो कह रहा हूँ
confusion.
गैप 2 मीटर हो जाएगा तो क्या होगा?
नहीं वही इसीलिए पूछ रहा सर, उस पर्टिकुलर उसका हमको वॉल्यूम
You
नहीं
tell
निकालना,
me
कंसीडर
that
नहीं
water
करना.
is displaced by the pontoon, yes or no?
यस सर.
Is that displaced by the pontoon in
नो
between?
नो दैट इज नॉट डिस्प्लेस्ड सर.
So why do you call the ship's weight as displacement? Because it is the weight of the water displaced by the ship. Do you know why the weight is called as the displacement?
करेक्ट सर. जितना वॉल्यूम
The ship's
डिस्प्लेस
weight is
करेगा
called displacement because it is the weight of the water displaced, correct?
करेक्ट.
So when you have lowered the pontoon, how much water is displaced by the light pontoon? It is only the volume of the cylinders,
Volume
yes
of
or
the
no, up to
cylinder.
4 meters,
Yes.
correct, Pete?
करेक्ट.
No, if you're not satisfied, let me know. We can.
नो satisfied.
Okay, fine. Okay, good. So first we calculated the light displacement. Now what happens is you ballast it up to, okay, what is the light kg, guys? Light kg is given in the question 3.6 meters. These pointers are coming here, okay? Okay, let me just
sir, one
go
more.
by what is written
Sorry,
here.
sir,
Sorry, 1 second. Okay, now everything will go off actually. So let's
sir,
continue.
just a minute.
No, I'm not deleting. Don't worry. I don't want to do it again. Okay, no problem. I'm not deleting anything. Don't worry, better.
No,
Okay.
one more doubt, sir.
Yeah.
सर ये अपना पाई r square होता है सर, तो diameter is 4.
So we have taken the radius as 2, na? We have made square of 2, beta. 4 is the draft to make it volume.
Okay.
ड्राफ्ट में कंफ्यूजन हो गया.
ठीक है सर, that is also 4 man.
It's okay. Can we continue then?
Yes, sir.
Okay. Light kg 3.6 meters given in the question, beta. Now, in the light condition of the pontoon, is there any FSM, guys? Read the question and tell me, is there any free surface in the light condition? What is the light condition FSM?
No, sir.
No, sir.
Nil. Okay, fine, very good. These are the things. Now, you take ballast. Ballast taken. Now we'll find out how much ballast is taken. Ballast is taken to a sounding of 2 meters, guys, like this. See the diagram? I think that the diagram is making it absolutely clear now.
Yes, sir.
This is 2 meters sounding. What will be the weight of the ballast? It will be the volume of the ballast multiplied by 1.025. Correct, bete?
Yes, sir.
So it will be the volume of ballast in one drum plus the multiplied by 2 multiplied by the density. So in one drum it will be pi r square, and now 2 is the sounding. This is the volume of the ballast in one drum multiplied by 2 to make it for 2 drums multiplied by 1.025 to make it as the weight of the ballast. How many tons is the weight of the ballast, guys?
51.5.
51.5 tons. Anybody who's not understood it, let me know.
Yes, sir, 51.5.
Okay. All happy up to this point?
Yes, sir.
Okay. What is the final displacement? Now we can get the final. Okay, no. Then there is a weight placed on deck.
Yes.
How
sir.
much? 2 tons.
2 tons.
So ballast kg. What is the kg of the ballast? Look at the diagram. What will be the kg of the ballast, guys?
3.6. Sorry.
Of the ballast taken. What is the kg of the ballast?
1 meter, no? 2 meter sounding then.
1 meter. Anybody has any doubts?
No, sir, 1 meter.
1 meter, okay. Kg of the ballast is 1 meter. Let me write here. Weight on deck, 2 tons. Let it come on the diagram. The weight is placed on any one side. Doesn't make a difference whether port or starboard. This is the fore and aft axis. Now somebody may say, why are we taking fore and aft like this? Why are we not taking fore and aft the other way? Guys, when you pull a pontoon, you would like the water resistance to be minimum. Yes or no, beta? Correct? Correct? Am I right?
Yes, sir.
So that justifies why this is the fore and aft direction. Does everybody agree, or there is any doubt as to why this is fore and aft and not this way? बोलो भाई किसी को बाद में मत बोलना. I hope nobody feels that this should be the fore and aft where my laser is running. Why? Because if this is the fore and aft, and if I pull the pontoon like this, I will experience extra resistance by both the cylinders. When I pull in this direction, the resistance will be least. So that is what is going to define the fore and aft axis of the pontoon. Correct, Peter? Understood?
Yes, sir.
Okay, fantastic. Now, what is the kg of the weight on deck? Read the question and see.
15 meters.
15 meters. Okay, very good. So now what is the final displacement? It will be equal to initial displacement 103.1 plus the water taken in the well as ballast. This will become 154.6 tons. Am I right, guys?
Sir, 2 tons.
Sorry, yes. Thank you very much. Thank you very much.
156.6.
156.6 tons. Thank you so much.
Yes, sir.
156.6 tons. So far clear, beta?
Yes, sir.
Okay. Okay. Now, can we calculate the final kg by principle of moments? I would like some of you to write the step and do it. Then I'll write. Calculate the final kg. You know the light displacement, you know the light kg, you know the ballast kg, you know the weight on deck, you know where the weight kg. Please calculate.
2.89, sir.
Okay, let's see what others get, beta.
Yes, yes.
How much is the kg you are getting, guys? I have written the expression on the board.
2.824.
2.8?
2.890.
2.890. Okay. Any questions up to kg, guys? So, देखो, what were we required to calculate? The final displacement we already have. We were required to calculate final kg. Yes. So we already have. And we need to calculate the remaining missing things now.
KB and BM.
First, yeah. So for KB, what do I need, guys?
Draft.
Draft. Very good. Now let's calculate the draft final. Draft final will be equal to the final displacement 156.6 divided by 1.025. This is the final underwater volume or underwater volume in the final condition. Okay. What do I divide with it? In the last question, we had divided by length and breadth. What do we divide in this case? Anybody?
Pi r square h.
Pi r square h will be the volume, beta. ये h क्यों तुम्हारा गलती से निकल जाता है क्या हर बार?
2 into pi r.
This h is always going to come out of your thing in a intuitively, is it? Without any logic, is it? Because the area of the base you had used in the last question, which was length into breadth. Here, the area of the base will be this area and this area. Yes or no, beta?
Yes, sir.
So it will be pi r square for one circle multiplied by 2 for both the circles, and this will be the final draft. See, if you do it systematically, you will not get confused. Don't try to calculate multiple things at the same time. We get bogged down. We try to start thinking when calculating kg, focus should be only on kg. When calculating kb, focus should be only on kb. Don't allow your concentration to wander here and there. That is our root cause, beta, of all the issues. How much is the final draft?
6.076.
6.076 meters. If anybody has any questions, anybody has any questions on the final draft, you can ask me.
No, sir, but 6.078 आ रहा है. ठीक है सर.
078 आ रहा है. That तूने क्या 3.14 लिया है? क्या लिया है?
नहीं सर, मैंने 22/7 लिया.
Okay, just others can somebody validate? Is it 6.076 or 6.078?
6.076, sir.
Better than you check your calculation. Okay, it is 6.076. Okay. Okay. We can draw the water line on the diagram now. This is the final water line, and this draft is
final draft
6.076 meters. Correct, Vite?
Yes.
Okay. Now, this much of underwater volume is the underwater volume in the final condition. Correct, bete?
Yes, sir.
Okay. What will be the KB in this case now? Final KB. Just give me the relation, not the value. I'm not interested in value. Final KB. Beta, when initial, what will be the final KB? It will be the geometric center of this underwater volume, yes or no?
Yes,
What is
sir.
B?
Sir.
B is the geometric center of volume of buoyancy, correct, beta? What I have shaded here is the volume of buoyancy. Where will be its geometric center from keel?
Half of draft.
Say with conviction. Why are you saying half-heartedly?
Half of final draft.
Yes, yes,
sir.
it is. But unless you are convinced that you are just
3.039.
taking a chance and tossing a coin, don't say. So it will be draft final by 2, 6.6 by 2 equal to 3.038
38.
meters. Everybody is good up to KB now. Please let me know.
Yes.
I will take the print screen of this and paste on the next.
Sir, how can it be draft by 2, sir? I mean,
Why was it draft by 2 in the last question? What was your logic in the last question?
तो बॉक्स शेप था ना सर लास्ट को
तो नहीं बॉक्स शेप का क्या मतलब हुआ?
ज्योमेट्रिक सेंटर तो सर ये दोनों सिलेंडर्स का एग्जैक्टली मतलब हाउ कैन वी डिवाइडेड बाय 2?
Where you have a glass in front of you?
I have a cup. Yes, sir.
So you have a cup. Okay, it's a cylindrical cup.
Yes, sir.
If it is half full of tea, okay, ignore the thickness of the base. Ignore the thickness of the bottom of your thing. Let's say the thickness is negligible. If it is half full, that means it is, let us say, 3 centimeters full of tea. Where from the base, from the table where it is kept, where will be the geometric center of the tea now?
So exactly at the center. So, but my doubt is over here we have 2 cylinders, और दोनों के बीच में we have a gap. So
how does that change the KB? Does that change the KB?
Okay, because they're connected through the same platform on top.
It doesn't make a difference whether they're connected or not. Does it change the KB is my question. So
No,
these are the 2 cylinders. And here is the water line. Where will be the geometric center of this underwater volume? It will be here at G1. Where will be the geometric center of this volume? It will be here at G2. Where will be the combined geometric center? It will be somewhere here. Does it change the vertical distance? Yes or no?
No, sir, it won't change. Okay, got it, sir.
Correct?
Yes,
but
sir,
it will be the B of the pontoon will be here. I agree with you. It will not be in any of the cylinders, right? But it will not change the height.
Yes, sir, and we are concerned just with the height. Okay. But sir, 3-dimensionally अगर हम इसे देखें, but even like ये तो 2D डायग्राम बनाया आपने, अगर हम 3-dimensionally देखेंगे तब भी वो इधर ही आएगा.
It will be between the 2 pontoons, no? Where will it come else otherwise?
Okay, understood. ठीक है सर, कील से ले रहे हैं हम तो 2 मीटर होगा. Okay, got it.
No, where is the where is the geometric center of this? This is from here. This is here. So their combined geometric center will be midway, right?
Correct. Okay, sir, got it.
So it will be basically 2 plus 0.5. It will be 2.5 meters from this side like this and 2.5 meters like this, right? But yes, the height will remain same, no?
It will remain same, correct. Yes, okay, sir.
Okay, anybody else before I clear this diagram? Whatever we worked on the previous sheet is already here. So you don't have to worry about what we calculated there. So whatever is calculated, is that clearly visible on this diagram, beta? On the screen now? Okay. Now what are we left? KB is obtained. KG is obtained. Now it is BM. Look at the diagram. Diagram is very much here. Where is the ship? Ship is floating at WL, red one, red water line. Guys, visualize the shape of the water plane for BM. For BM, now we are calculating BM, okay? For BM, what do you need to visualize? Shape of the water plane. What will be the shape of the water plane at the final water line? At the final water line. Who's
The
going
two
to tell me?
circles.
Two circles.
Circles.
Very good. Two circles.
Two
Very good.
circles.
Two circles. Yes or no?
Yes, sir.
So the shape of the water plane at final water line. It may be same at all water lines, but what I should be interested in is at final water line. Tomorrow it changes. Why should I worry then? The shape of the water plane at final water line will be one circle here of diameter 4 meters, another circle here. What I have drawn in red is the water plane area. Do you agree with me?
Correct, sir.
Okay. Guys, where will be the center of flotation? Geometric center of this water plane. Here is the geometric center of this
Both-
circle. Here is the geometric center of the other circle. Where is it going to be the geometric center of the combined area?
Center of this both circles.
Somewhere here. Correct, Bete?
Yes, sir. Yes, sir.
This will be the center of flotation. Why I have marked it as F? Because I'm drawing water plane area. Please don't get confused. Is that clear, Beta? Does everybody agree the center of flotation will be here and this will be the shape of the water plane area? Anybody who doesn't understand or does not agree, please let me know. Tell me, Beta. Bol bhai, is done?
Yes, sir.
Once we find the center of flotation for BM, what is the next step? Next step is you draw a 4.5 axis through center of flotation. So we draw the center of 4.5 axis through the center of flotation. Is this the center line? Yes, fortunately. So what will be BM equal to? BMT will be equal to I about TL of the water plane, intact water plane upon volume of displacement. My intact water plane comprises of two areas, 1 and 2. Both are identical, so it will be 2 into ICL of one circle divided by V. Do you agree with me? Yes or no? Correct, beta?
Yes, sir.
And guys, is this center line a standard axis for the circle? Yes or no? Is it a standard axis for the circle?
Yes, sir.
Yes, sir.
Yes. So pi d4 upon 64 or pi r4 upon 4, whichever you want to use, correct? Correct, beta? About the diameter of a circle, the moment of inertia is what? Pi d4
correct.
upon 64 or pi r4 upon 4, right?
Correct, sir.
So now it will be 2 into, I'll use d, no problem, 22 by 7 into d raised to power 4. D is 4, sorry. D itself is 4 raised to power 4 upon 64. This is the moment of inertia. And I need to divide by volume of displacement. What is volume of displacement? What is the final displacement? 156.6. In which density? Seawater, 1.025. And when I solve this, this will give me the BMT. If anybody does not understand this, you are welcome to raise your doubts as to what they are. Those who are clear can calculate. I'm getting it as 0.165, right? I've calculated parallelly. I'm getting it 0.165 meters, but you can see, you
Yes.
can let me know if there's any doubt. Because if you understand this, then the third thing is calculated. Anybody in the class who has questions to ask on calculation of BMT beta? It's a MMD question. So here is the calculation of BMT in the blue box. Class, is that clear? I'm not getting any response. Have you understood or you have any doubts?
Yes, sir.
Understood, beta? Please remember what I have drawn is the water plane area. And since what was drawn was water plane area, we called its geometric center as center of flotation. If it is anything but water plane area, if it is anything else but not water plane area, then we will not call it as F. Then we can call it as geometric center, but not as F. Am I clear? F is the geometric center of only the water plane area. Understood, guys?
Yes, sir.
Can I continue if there are no doubts then? So if you see this list formula, we were to calculate the final displacement we have. We were to calculate the KB, we have done. We have to calculate the BM, we have done. We have to calculate kg, we have done. And what is left is FSC, for which you need to calculate the FSM. Look at the diagram on display, the old diagram, which is still visible on the screen. Guys, do you think the ballast taken has a free surface? Yes or no?
Yes, sir.
Initial FSM you said was 0, but now is free surface created?
Yes, sir. It's very good.
Okay, now I'm doing here. Guys, please look at the diagram which is already on display, and that should make it very simple for people to visualize. That's why I made this diagram. What is the shape of the free surface? What is the shape of the free surface?
Cylinder.
Circle.
Surface is two-dimensional. Cylinder is a three-dimensional. How can the shape of a free surface?
Circle, sir. Two circles.
Two circles. Does everybody agree?
Yes, sir.
This is the free surface, beta. Here, देखो, ये this is the free surface. This is the free surface. Yes or no? This one, where I've done the blue. Let me use the laser. Guys, don't you think this is the free surface? This blue surface here is the free surface. Yes or no?
Yes, sir.
See, water plane we visualized here at the red water line. Now we are visualizing the surface at 2 meters sounding. There's a difference. The shapes may be same, but please understand there are two different things that we are talking about. Is that clear? Am I clear, beta?
Yeah, clear, sir.
Yes,
So
sir.
the shape, the free surface will be again two cylinders, each of 4 meter diameter, separated from center to center by 5 meters. And that's why I've changed the color of my pen. PM calculation was water plane diagram, and that's in red. Now this is the shape of the free surface. And since it's not water plane, we will mark its geometric center as G. Where will be the geometric center of the free surface, beta? Since the free surface comprises of two components, this one and this one. Where will be the geometric center? It will again be here, yes or no? Correct?
Correct, sir.
But I'll not call it as F, I'll call it as G. because this is not the geometric center of the water plane, it is the geometric center of the free surface. Both diagrams may be similar looking, but both diagrams represent different things. And for free surface, FSM caused, what do I need to do? Through G, I will draw a 4.5 axis, which we learned today. And I'll call it as GG. Correct, beta? Yes or no?
Yes, sir.
Yes, sir.
Okay. So IGG will be equal to I of one circle multiplied by the I of the second circle. Sorry, IGG of one circle multiplied by 2. My mistake. Sorry, beta. So this will be 2 into pi T4 upon 64. And this is what it will become. How much does it come, beta? Can you calculate and give me? This will be so many meter 4. Or you can leave it like this also, no problem. Oh, but you'll have to calculate.
$25.12 per meter.
35,
25, sir. 25.1.
25, आगे point.
0.12
Is it point or something? 25,
decimal
25 decimal.
12.
इतना तो नहीं होना चाहिए because 4, 16, 16, 16 square है. देख लो एक बार calculate करके. Maybe if it's coming that much, then it must be right. 2, let me also calculate. 2 into 22. 16 into 16 divided by 7 and divided by 64. You're right, 25.143. Correct, beta? 143.
143.
143. 25.143 meter 4. So what is the FSM cost? FSM cost will be equal to IGG into the density of the water. It will be 25.143 into 1.025. So we multiply this by 1.025. That gives us 25.771. Am I right, guys? Ton meter. Correct?
Yes, sir.
Guys, anybody has any doubt up to FSM caused because of the ballast taken? And what is the FSM initial? 0. So what is the FSM final? 25.771. So what is the FSC in the final condition, beta? It will be FSM final upon displacement final. 771 divided by final displacement is 156.6. Please see, this will come back to 0.165 meters.
Yes, sir.
Now, this question should put all your doubts about water plane area, free surface, FSM, and BMT in a clear perspective, because both diagrams happen to be same, but every time we said one was drawn at the final water line, other was drawn at the level of the free surface as 2 meters. They happen to be same, that's in coincidence. But please see, we've got no beta. Once we get the final FSC, we are good to get the GM final. GM in the final condition will be equal to KB. It's there on the side, on top beta, in that screenshot appended on top. KB was 3.038 plus BM 0.165 minus kg. Kg was 2.890 minus FSC 0.165. How many meters is the GM beta?
Point one
0
four.
decimal
Yeah. 0 decimal
265.
265. Is that correct, beta?
Point 148 है मेरा.
Maybe they, let me just see, minus 0.165.
One,
It's
Sir,
148, beta. It's
0.148.
0.148, yes sir.
Yeah, it's, oh, never mind, it's okay. It's 0.148 meters, beta. Now we are good to get the list. Look at the list formula written on top. Tan theta is equal to W into D upon W into GM. All final values are available. Small w is 2 tons, small d is 2 meters, final displacement is 156.6, final GM is 1.48. Multiply and do tan inverse, you will get the value of list, which comes to 9.725 beta.
9.792.
725 is at what I got, maybe a rounding of issue. You can just 9.725 is what I have written there, maybe subject to correction, no issues. That is how this question gets completed. You have to deal with things one at a time. Don't allow your mind to be cluttered thinking of 20 things simultaneously. If you do that, you'll get confused, beta. If you keep it simple, you'll be through and through. You'll run through with the things.
Sir, can we get 5 minutes break so that we can?
Yeah, मुझे पता था इसके बाद 5 मिनट्स का तो, पर समझ में आ गया, पहले ये बताओ, ब्रेक तब देंगे, पहले
समझ आया.
everybody has to
समझ
say
आया,
that
sir.
they've understood.
एक बार एनालाइज कर लेंगे.
Anybody who wants to take the screenshot can take the screenshot for later reference, beta. This has the complete calculation. The previous part of the calculation is also there. The drawings are there. Everything is there. Okay. There's only one more question left, I think. I think there's no more question. I think, yeah, that's the last. It's your choice. You can take, okay. Take a break, no problem, no worry. What time do we connect? What's the time? Time is 11:20, 11:30, beta. Good at 11:30.
Yes, sir.
Yes, sir.
11:35. चलो ठीक है, because it will spill over a little bit. So ठीक है, okay, 11:35. It's okay if you have said so. No problem. 11:35, okay.
ठीक है
Okay.
सर.
Okay. Okay, guys, shall we? Guys, can we start? If you're back.
Yes, sir. Yes, sir.
Okay. Okay, here is the next question on display. An undivided DB tank of length 18 meters has the following half ordinates of waterline at equal intervals measured from forward bulkhead. Excuse me. Fuel oil of RD 0.9 is loaded to a sounding of 0.8 meters in the tank. Assume the tank to be wall-sided. Determine the kg fluid in the final condition. If the initial kg and displacement are given, it's a MMD 2020 question beta. Okay. Firstly, let's understand the meaning of few words. Some of you may be aware of it. If these are given half ordinates of the water line, what does it mean, beta? What are these given? These ordinates are for what?
Ordinates.
Of what? Of what, beta? These are ordinates of what, beta?
Bulkhead, sir.
Sir, breadth.
Breadth of the
Sorry?
tank, sir.
Water plane area.
Breadth,
Sir, half breadth.
half breadth.
Yeah, but where? These are the ordinates of the free surface, beta. Water line in the tank, okay? That's what it means. And I have not changed the language. This is a MMD question language, okay? So don't tell me it could have been worded better or whatever it is. The way it is there is in front of you. So it says DB tank, it's a tank whose half ordinates at the water line. That means at the level of the water surface. So these are the free ordinates of the free surface, half ordinates of the free surface. Clear, beta? Yes or no? Is it clear these are the half ordinates of the free surface? Yes or no?
Yes, sir. Okay.
Okay. So it's very important to understand the question. Fuel oil of RD 0.9 is loaded to a sounding of 0.8 meters in the tank. Assume the tank to be wall-sided. Again, an important word here. What does wall-sided mean? Sided means that the sides may be curved, maybe whatever it is, but sides are vertical. That means from the bottom of the tank to the top of the tank, everywhere the areas are identical. Like you have in the glass, everywhere it is circular. In a box, everywhere it is rectangular. Okay, so here what is he saying? The word wall-sided means that area is the same. That means if I need to calculate the volume of the oil, I can multiply the area with the sounding and I'll get the volume of the oil. Is that clear? That is the meaning of the word wall-sided here. Understood, beta? Understood, guys? So firstly, the given ordinates are the ordinates of the free surface. Secondly, the tank is assumed to be wall-sided as per the question. So is the question clear now, beta?
So wall-sided
Yes,
and
sir.
this box.
Sorry, beta. Say again. You're trying to ask something. I couldn't hear you.
So this wall-sided and box shape, all are
No,
same.
box shaped is rectangular, beta. Wall-sided can be any shape. The sides are vertical.
Okay. Only side will be vertical.
Like your cylindrical glass is also wall-sided, because whether you see the area at the bottom, you see the area at 2 centimeters, you see the area at 5 centimeters, you see the area on top, everywhere it is circle only, right?
Yes, sir.
So your a cylindrical tank is also wall-sided because the sides are vertical, right, of the cylinder. Understood?
Only that sides are vertical, that means.
Yeah, so that means the area will be same. The shape of the area need not be rectangle or square. It can be any shape, right?
Okay, so area can be
Any shape. Area can be any shape, no? Curvilinear, any regular geometric shape, correct?
area will be uniform and initial.
Area will be same from top to bottom or bottom to top, right, beta?
Okay, okay. Okay, sir.
Understood, guys? Okay. Okay. So now what I'll do is I'll draw the water plane free surface whose ordinates are given. They are given from forward to aft, and I'll draw the free surface. And you can tell me if you do not agree with what I have drawn. This is the free surface, and the half ordinates are given. And these ordinates are from forward to aft as given in the question. Do you agree with the diagram, Bete?
Yes, sir.
This is
Yes.
the diagram of the free surface. It's a different matter that the tank is also wall-sided, but this is the diagram of the free surface. Understood? Other half will be exactly identical. So there it is. Now we have to get the fluid kg, guys. Fluid kg is kg corrected, which you used to use in GZ curves. So what do we mean by kg fluid? By kg fluid, we mean kg solid plus FSC. That is what we mean by the kg fluid. Understood, beta? Understood, guys?
Yes, sir.
So that means the question here is we'll have to calculate the kg and the FSC. Since no other tanks are mentioned, we'll assume that the initial FSC is 0. Had he given the initial FSC, then he would give the displacement also, then it's a different matter. But since he's not given, we'll assume that there is no initial FSC. What is given to us, beta? We are given is the initial displacement. How much is that? 20,000 tons. We are also given the initial kg. How much is that? 10 meters. This tank was empty when the initial displacement and kg are given. In that condition, the tank is empty. Now you basically take oil up to a sounding of 0.8 meters. RD of the oil is 0.9. So what will you do? How will you find the volume? You will basically find the area of the surface, multiply by a sounding. That will become the volume of the oil. Yes or no, beta? Correct? We
Yes.
have to find the
Yes,
weight
sir.
of the oil that is taken. And volume multiplied by density of 0.9 will give you the weight of the oil. Can you all get the weight of the oil if the need be? Have you understood how to get the weight of the oil? We'll calculate together later on. First, let's understand the steps. Okay. Now, second thing is, it's a wall-sided thing. What will be the kg of the oil, beta? I gave you example that your glass is also wall-sided. So
0.4.
what will be the kg of the oil?
Half sounding 0.4.
Half the sounding. Very good. Does everybody agree?
Yes, sir.
Why? Because tank is wall-sided. Okay. Then the question does not say what is the height of the tank. It does not say the tank is slack. But whenever we have doubt in ship stability, whether the free surface is created or not, whenever such a doubt arises, we shall always assume that the free surface is created. Okay, that is one. Secondly, he is giving you at the water line. Otherwise, if the tank was full, he'll say at the tank top, the dimensions are this. So both ways, it basically propels us to assume that the tank is slack. Even if you don't agree with any other argument, simple argument is whenever you have doubt, is free surface created, you shall assume free surface is created because that's an assumption on the safer side. So that means I'll also have to calculate the FSM caused in this tank. Now, when you talk about the FSM caused in this tank, look at the diagram of the free surface. Guys, will the geometric center of the free surface lie on this line, yes or no? Will the geometric center lie on this line, yes or no?
Yes,
Yes,
sir.
sir.
And then this line becomes the fore and aft axis through the geometric center of the tank. Yes or no? This becomes x-axis the okay. Mark x-axis. No,
Yes.
x-axis is the fore and aft axis through the geometric center of the free surface. Yes or no? Correct, beta?
Yes, sir.
So what will be FSM equal to? FSM will be equal to I about XX into the density of the oil. Yes or no, beta?
Yes.
So in that case, is it a case of vertical ordinates or horizontal ordinates?
Vertical.
Vertical.
So can we work around GG directly, XX directly? Can we work about XX directly? Yes. Why?
Yes.
Because all the half ordinates are terminating at XX. Am I correct, beta?
Correct.
Yes, sir.
Okay. So basically, what will I do? One, I will use the vertical ordinate concept and make the table. About which axis will I take the moments? I'll take about the x-axis. And then we'll go on to close out the question. And for vertical ordinates, you know what is the format. First, you will write the ordinates. After the ordinates will be Simpson's multipliers. After the Simpson's multipliers will be product of area. If these are half ordinates, it will give you half area. Then you will repeat the ordinate again. It will give you product of moment about, in this case, x of half area. Then you'll again repeat the ordinate. It will give you product of inertia about x. So I'll clear what I have written here, and then I'll take you through. Okay. Okay, this is the diagram we have made. This is x is the axis. Okay, now this will be the format of the table. You're taking half ordinates. It will give you product of area of half or area. It will give you product of moment of half area about xx, and this will give you product of inertia of the half area about xx. Do you agree with the table format, guys? Yes or no?
Yes, sir.
So now you can write down the ordinates. Now, 7 ordinates you can do by rule 1 or 2. I have solved it by rule 1 beta. I have not solved by rule 2. If you want, you can solve by rule 2. Answer will be different, but if it is correct, then it is correct. No issues. I have put the half ordinates here. I have the Simpson's multipliers 1, 4, 2, 4, 2, 4, 1. I repeat the half ordinates. I repeat the half ordinates. I complete the table. You please complete the table. And then we get the summation. Please see up to the summation and finalize. Why we have used the summation? Because we are using vertical ordinate concept. So we will not directly get SOP moment and SOP inertia. They are subject to being made half and 1/3.
Yes, sir. Ordinate, sir.
Yeah, so then you can, in the next one, you can write down the SOPs beta. Next line. You can work out the SOP half area, SOP half moment, and SOP half inertia. And since it's a MMD question, you can expect questions being repeated, papers being repeated. And of course, this also prompts people who are setting papers to be driven by such questions to set by changing the values. This will give us SOP area, half moment, and half inertia. Any questions up to this point, beta? And what is drawn here is nothing but free surface. This is the free surface in the tank. This is not the water plane, don't confuse. Understood, beta? let me know once you have reached here, then I'll continue further better. Anybody who's still making the table and completing it, please just confirm once so that I know I have to continue getting no issues.
Done, sir.
Done? Chal, let's continue then. Okay, guys. Now, what will be the area of the free surface? Area, and which will be the area at every level. Why? Because it's a wall-sided thing. So area will be equal to twice into half area, which this table will give you. This will be 2 into, we have used rule 1, so 1 by 3 into common interval. Now, what is the length? 18 meters. So 1, 2, 3, 4, 5, 6. I'm sure all of you will agree that H will be 3 meters. Yes or no, beta?
Yes, sir.
1 by 3 into 3 into 96.1. This will become 212. 192.2 square meter is the full area of the surface. Yes or no, beta? I've already doubled it up, right? Agreed?
Yes.
Yes.
Now, once we have the area, we can get the volume of the oil. So W, weight of the oil, will be equal to area
And
192.2, yeah, into the sounding 0.8 into density 0.9. So
9.
many tons. How much it comes to, beta?
One 138.384.
138.384.
384. So like, can I take 138.4? It's okay, I think, right?
Yes, sir. Yes, sir.
Okay, guys. Now we are good to basically get the final kg. Okay. Initial displacement 20,000 tons. Initial kg 10 meters. So what is the final displacement? Final displacement is 20,138.4 tons. Final kg will be equal to initial vertical movement, that is initial displacement multiplied by initial kg
kg
plus
plus
the vertical movement of the oil. Kg of the oil will be half the sounding. 138.4 into 0.4 divided by the final displacement. How much is the final kg coming, better?
$9.93.
93
Yes.
0, is it?
Yes, sir. 9.934 actually.
934, okay.
Yeah.
Is that correct, guys? Can somebody else validate?
Correct, sir. Correct. 9.934.
Okay, fine. Now, next we write is assuming the tank to be slack. Okay. The FSM cost will be equal to So let's talk of I first, okay? I of the pre-surface will be 2 into I of half area, and this will be equal to 2 into, we have used rule 1, so 1 by 3, common interval 3, and SOP inertia is 1477.132. Okay, this 3 and 3 gets knocked off. This becomes 4, 6, 2, 14, 15, 29, 29, 54.264 meter raised to power 4.
Yeah, 2954.264.
Yeah, so this gives us FSM caused. It will be 2954.264 into the density of the oil 0.9. So many ton meter is the FSM caused. How much is that, Peter?
2658.8.
2658.8 ton meter. Okay.
84.
84. Okay. 84 ton meter. Okay. FSM initial, no mention, so 0. FSM initial 0. So this is how we'll continue doing initial 0. This gives you FSM final equal to 2658.4. This gives you FSC final as 2658.4 divided by final displacement 20138.4. How much it comes to?
0.132.
0.132 meter.
Yes, sir.
Yeah. So now we come here. kg,
corrected.
Yeah, kg fluid or kg corrected will be kg solid, which was 9.934.
Yes, sir.
Plus the FSC of 0.132. It gives you
10.066.
10.066 it is coming. That must be because of the rounding of that I have done, because here I rounded off this. Yeah, so that's a rounding of issue. So that is the answer. Whatever the answer comes, whether it comes to 10.060 or it comes to 10.066, it's okay. That is your answer to the question. That is the corrected kg. It's a MMD question, so be wary of it.
Yes, sir.
Anybody has any questions, please let me know. Otherwise, I'll take only 5 to 7 minutes more to discuss one doubt which came in the first or the second batch. After that, people have not brought it up. I'll just take that quickly so that I'm able to finish off all that is in this particular presentation. Okay. We go to the, yeah, tell me.
Sir, can I just log out and log in again, sir? I think my screen has
Name.
Harpreet Singh, Harpreet.
Okay, go out and let us know when you're back.
Okay, sir, copy.
Sir, just one small doubt.
Yeah, tell me.
The only reason we could halve 0.8 for finding the kg is because they